homolog series of alcohols. Alcohols are non-hydrocarbons. It is a homolog series of organic compounds containing not only the elements carbon and hydrogen, but also oxygen. Alcohol contain the hydroxyl group OH as their functional group. The hydroxyl group is the part of the alcohol molecule which determines its chemical properties. Hydroxyl group is covalently bonded to a carbon atom. It should not be confused with the hydroxide ion. There is no hydroxide ion in an alcohol molecule. Alcohol do not show alkaline properties. In fact, alcohols are neutral compounds. Alcohol may be considered to be derived from an alkane by the replacement of one hydrogen atom by the hydroxyl group. So the general formula of the alcohol family is CnH2n plus 1 OH, where N is starting from 1. In naming alcohol, by using this structure formula, the first step, number the carbon atom in this straight chain, beginning at the end nearer to the hydroxyl group, to ensure that the hydroxyl group always receive the lowest possible number. So we look here, when we numbering this carbon atom, 1, this carbon atom, 2, the position of hydroxyl group at carbon number 2. How about from here? When we number from here, number 1, carbon number 2, and carbon number 3. The position of hydroxyl group at carbon number 3. So the nearer carbon atom with hydroxyl group is from left. After that, name the alcohol by removing E in alkane name. So, 4 number of carbon atom relate with butane alkane by removing E. So, butan. Next, identify the position of the hydroxyl group by writing the number of the carbon atom to which it is attached in front of the ending "ol". So, the position of hydroxyl group in this structure formula at carbon number 2. So this molecule is butan 2-ol. How about this structure formula? Which carbon nearer with the hydroxyl group? From here, carbon number 1, 2, 3, the position of hydroxyl group at carbon number 3. How about from here, carbon number 1, carbon number 2? We choose from here because this carbon is nearest with the hydroxyl group. And next, name the alcohol by removing E in alkane name. So in alkane, 4 carbon atom relate with butan because we remove E. And next, identify the position of hydroxyl group at carbon number 2. This molecule is butan 2-ol. So when you draw the structure formula like this, or we draw the structure formula like this, it's still the same molecule. Let's try another one by using this structure formula. First, number the carbon atom in this straight chain beginning at the end nearer to the hydroxyl group. Carbon number 1, carbon number 2, carbon number 3, carbon number 4. The position of hydroxyl group at carbon number 1. When we numbering from here, carbon number 1, 2, 3, 4. The position of hydroxyl group at carbon number 4. So, here is the nearer carbon atom with the hydroxyl group. Name the alcohol by removing E in alkane name. So, in alkane name, 4 number of carbon atom. butane. Identify the position of hydroxy group. The position of hydroxy group at carbon number 1. At the end, we put all. This molecule is butane 1-ol. Or this structure formula. Number the carbon atom. The nearest carbon atom with the hydroxy group. Carbon number 1, 2, 3, 4. The position of hydroxy group at carbon number 1. When we numbering from here, 1, 2, 3, 4. The position of hydroxy group at carbon number 4. So, this carbon is the nearest with hydroxy group. 1, 2, 3, 4. Name the alcohol by removing E. 4 number of carbon atom in alkane, butane, but we write without E. Identify the position of hydroxy group at carbon number 1, ending with OL. This molecule is butane 1-ol. When you draw the structure formula like this and like this, it's still the same molecule. But this structure formula and this structure formula, butane 2-ol, butane 1-ol. This molecule are called isomer. 2-methyl propan 1-ol is the isomer for butane 1-ol. How can we draw the structure formula for this molecule? The first step is you find the parent chain, propan. Refer to number of carbon atom, propan, 3 number of carbon atom. 3 number of carbon atom, numbering from here 1, 2, 3. And then the position of hydroxyl group in the molecule. 1. Hydroxyl group located at carbon number 1. You can put here, you can put here, or you can put here. And then methyl is the side chain. So methyl. Methyl is alkyl group. In alkane, methyl contain 1 number of carbon atom in the molecule. Refer to methane. Where's the location of methyl? At carbon number 2. Carbon number 2. The structure formula for methyl, CH3. At carbon number 2, you can draw methyl here or here. You can choose either one. Carbon number 2. And then fulfill other sharing single covalent bond with hydrogen atom. This is the molecule 2-methyl propan 1-ol. Physical properties of ethanol. Ethanol is a liquid at room conditions, colorless, has a sharp smell, completely miscible with water, has a low boiling point, about 78 degrees Celsius, highly volatile. Ethanol volatile liquid, and when going down the homolog series, the volatility properties decreases. Why? When going down the homolog series, the number of carbon atom per unit molecule increases. The size of the molecule increases. The attraction force between molecule become stronger and more heat needed to overcome the force. And the reason also same to describe when ethanol has low boiling point, but when going down the homolog series of alcohol, the boiling point increases. 3 chemical properties of ethanol. 1. Combustion. 2. Oxidation. And number 3. Dehydration. Ethanol has a set of reactions determined by its functional group, that is hydroxyl group. Number 1. Combustion of ethanol. Ethanol is a very flammable substance. It readily undergoes combustion when heated in oxygen. Ethanol burns with a non-smoky blue flame. Complete combustion of ethanol produces carbon dioxide and water. Complete combustion of ethanol produces carbon dioxide and water. Besides carbon dioxide and water, the combustion of ethanol releases large amount of heat. The combustion of ethanol releases large amount of heat. This makes ethanol suitable for use as a fuel. It is described as a clean fuel. Why? Because it does not release pollutants into the atmosphere. Number 2, oxidation of alcohol. Oxidation reaction occurs when a substance combines with oxygen. In this reaction, oxidizing agents are needed. In the laboratory, acidified potassium dichromate 6 solution and acidified potassium manganate 7 solution are commonly used as oxidizing agents. Alcohol can be easily oxidized to carboxylic acids. What is carboxylic acid? A family of organic compounds which has the carboxyl group or COOH group. When acidified potassium dichromate 6 solution is added to ethanol and the mixture is warm, it turns from orange to green. It turns from orange to green. This shows that it has oxidized the ethanol to form ethanoic acid. When acidified potassium manganate 7 solution is used, instead it is decolorized. It is decolorized. Purple potassium manganate 7 is changed to colorless. Purple potassium manganate 7 solution is changed to colorless. Number 3, dehydration of alcohol. Dehydration involves the removal of water from a compound. Removal of water from a compound. In the dehydration of alcohol, a molecule of water is eliminated from each alcohol molecule. The alcohol molecule is changed into alkene molecule. The alcohol molecule is changed into an alkene molecule. This reaction can be used to make alkenes from alcohol. Alcohol remove water to form alkene. The dehydration of ethanol produces ethene. The elimination of a molecule of water results in the formation of a carbon-carbon double bond. The hydroxyl group is removed together with a hydrogen atom from an adjacent carbon atom. The ethene produced can be detected by the following tests. Number 1, it's decolorized brown bromine water. And number 2, it decolorized purple acidified potassium manganate 7 solution. There are two methods to carry out a dehydration of ethanol in the laboratory. And method number 1, ethanol vapor is passed over a heated catalyst such as unglazed porcelain chips, porous pot, pumice stone, or aluminium oxide. And method number 2, ethanol is heated under reflux at 170 degrees Celsius with excess concentrated sulfuric acid. Industrial production of ethanol. Ethanol is one of the most important alcohols. It is manufactured on a large scale by two main processes. Number 1, from sugar and starch by fermentation. Number 2, from petroleum fractions by hydration. The process chosen to manufacture ethanol depends on cost factors and on the end use of the product. Number 1, making ethanol by fermentation from sugars and starch. How it occurs? Yeast is added to sugar or starch and left in a warm place for several days in the absence of air. This process is anaerobic, which means it takes place in the absence of oxygen. Yeast releases biological enzymes which break down the sugars and starch into glucose. In this process, the enzyme called zymes slowly decomposes the glucose to form ethanol and carbon dioxide. The condition needs temperature 37 degrees Celsius, yeast as a catalyst, and other condition absent of oxygen. When the concentration of ethanol form reach about 15%, yeast is killed off and the fermentation stops. It is possible to produce pure ethanol by natural fermentation. The ethanol is then purified by fractional distillation. Number 2, making ethanol by hydration. It's called catalytic hydration, the direct hydration of ethene. Ethene is obtained from the cracking of petroleum fractions. An addition reaction combines ethene with water to produce ethanol. The condition needs temperature 300 degrees Celsius, pressure 60 atmospheric pressure, and phosphoric acid as a catalyst. The ethanol produced is condensed to form a liquid and the unreact ethene in recycle.